Hello, ladies and gentlemen, and welcome back. Welcome back. We're still looking at the 2009 Galois paper, but we're on our second question, question number 2. So hopefully you've given this one a try. If not, I encourage you to pause the video and try it out for yourself before watching further. A square has vertices with coordinates 6, 9, 12, 6, t0, I bet we'll have to solve for that t at some point, and 3, 3. So we're told it's a square, and that's fairly useful. Okay, well, before I start solving for t or whatever, but I'm sure I will, let's read our question. A, determine the value of t. Okay, there we go. Determine the value of t, the x-coordinate of vertex c. Okay, I think there's probably two ways you could try to go about doing this one. One way, and both of them I would suggest you draw a picture. It really shows that you illustrate what's going on, that you understand what's going on. D was 3, 3, so that's about here. And then it was 6, 9, 6, 9, 12, 6. So 6 over a bit, up a little bit more, and then 12 all the way over here. Then I guess C is got to be down here. B, 12, 6. And C is T0. Okay. So, one thing you can do, because you know it's a square, which is technically a rectangle. All squares are rectangles, not all rectangles are squares. Square is just a rectangle with the same side length on both sides. One thing you could do, I don't recommend it because it's going to be kind of long, is you could say, well, I know what A and D are. So I can figure out the equation of this line here. And I know that DC will be perpendicular to this. So, if I get the slope of AD, just do a negative reciprocal. And you can get the slope for CD. And then say, all right, well, it's got to pass through D. Get the equation there. And then figure out what the x-coordinate is from there by setting y equal to 0. So that's sort of one way you can go about doing the question. I don't recommend it because it takes a while. Okay? Just off the top of my head, however, could I think of what to do? Looks like 2 times... I think AD is 2x minus 3. You'd have to actually probably show why this is. And so then DC would be negative 1/2 x, and so that'll be negative 3/2, so that'll be plus 9 over 2. Yeah. And, you have to show this work. You can't just say, this is what AD is, this is what DC is. That's the point of a written contest. You have to justify, you have to show things. But from there, I guess you could say 0 is negative 1/2 t plus 9 over 2. And you're going to get t is going to be 9 fairly quickly. So that's one way to do it. Again, it's procedural, it's fine. It's probably what some people will jump to. Honestly, I think it would probably just be easier if you sort of ignore this and do a little bit of just sort of reasoning. Okay? So you could say something like, well, look at these two triangles here. Okay, and then this is in essence figuring out sort of slope. But these are going to have to be the same triangle. So this would go down to, so this goes to 3, 0, and this goes down by 3, so this is 6, 6. And so so what I would say is, these two triangles are congruent. And this distance here is 6, therefore this distance here is 6. And so once again, you say t is 6 plus 3 from over here, and that's 9. That's one of 2 different ways to do it. Obviously, I haven't written too much here, but I've sort of articulated 2 different ways to do it. One of which is very geometric, very intuition, let's draw some triangles. The other one is more algebraic, get equations for lines, get the relationship with a perpendicular line. Use whichever method you would prefer, as long as you write it up. It's question 2A. It's probably worth 2 or 3 marks, maybe. But I'm not really going to dwell on it. Okay. So 2B here. A line is drawn through the origin and D. Well, D is 3, 3, so this is just going to be the line y equals x. But we'll probably have to justify that in a second. This line meets AB at E. Determine the coordinates of E. All right, now the way they're asking this one, talking about line of AB, a line through the origin and D, makes me think that the way they want to do these questions is to actually work things out with lines. So actually, I think I will just do A here. I'm kind of disappointed in myself a minute ago, having not actually written much of a solution. So I think what I'm going to do is I'm going to write up A and B now. Okay? But I will do them both with the line AB. So here's me. I'm starting again. I'm just going to do A. So the equation, I'm going to do A, then I'll do B. So the equation of AB, well, I need the slope of AB, and that's rise over run. So that's 9 minus 12, and then, 9 minus 6 and 6 minus 12. 9 minus 6, 6 minus 12. This is negative 1/2. It's 3 over negative 6. Okay. A is on this line here. So y equals negative 1/2 x plus b. A is 6, 9, so it's negative 1/2 6 plus b. And so 9 is negative 3 plus b. B is going to be 12. So line AB has equation y equals negative 1/2 x plus 12. Okay. And then what could I do? Well, I could say something like CD is parallel to AB. So CD also has slope. So this is actually a third way to do it, not with perpendiculars and not with geometric drawing of triangles, just with parallel lines. So it also has slope negative 1/2, so y equals negative 1/2 x plus, again, I'll use b, and d is on the line, so 3 is negative 1/2 3 plus b. B is positive 9/2. So therefore the equation of the line is y is negative 1/2 x plus 9/2. Oh, I already figured that out a little while ago, but I'm redoing A to be a little more accurate, to show you what you should be writing down. So solve for t. So 0 is negative 1/2 t plus 9/2, which is 9 minus t over 2. Therefore, t is 9. Okay, I managed to fit it all in one page. But having done it this way, I have the equation for AB. So now that I do B part, I'm going to write B part up. So line through OD is y equals x. I would say this is fairly clear, but of course you can prove it. 3 minus 0 over 3 minus 0, if you need to, is 1. So the slope is 1. And y-intercept is 0, as the origin is 0, 0. Okay, so that's just a little side proof if you need the equation of the line through OD. All right, so, and what did we want? We wanted the intersection. Determine the coordinates of E, the intersection. Okay. So we set these two equal to one another. Y equals y. But one of those y's is x. The other one is negative 1/2 x. It was plus 12, right? Let's double check. Yeah, plus 12. Okay, well, we'll bring the 1/2 x to the other side, so that'll be 3/2 x is 12, multiplied by 2, 3x is 24, x is 8, and so since y is x, y is 8, so E is at 8, 8. Okay. And what lines do I have to work with for C part? Determine the perimeter of quadrilateral EBCD. All right, well, let's draw a picture. There's O. I mean, I did draw this picture a little while ago, but there we go. All right, so A, B, C. And now what do we need? So we'll make the square purple. We'll make the line through OD blue, and that hits E up here at 8, 8. Okay, and what do I want? I want the perimeter here. Okay, how am I going to get this perimeter? That is the challenge. Okay, so what could we do? I think we could probably just bash this out with the distance formula. I'm just trying to consider if there's a more elegant way to do it. And I don't think so. If there is, somebody please let me know in the comments. This guy is 12, 6. Okay. So we'll use the distance formula. If you haven't seen the distance formula before, if you've got 2 points, x1, y1, x2, y2, the distance between these two, if we call it d, d is just the square root of the difference in the x-coordinates, this distance here, plus squared, plus the difference in the y-coordinates squared, which is this distance here, squared, square rooted. Why? Because, well, Pythagorean triangles. Okay, it's the advantage of having your x and y axes perpendicular. So we'll just use the distance formula. If I'm about to use this formula or some other formula that I think maybe they don't know when they're marking, or maybe they're a little unfamiliar with, I'd mention it. It takes one line to say I'm using the distance formula, and to actually write it out. So what do we need? We need BE, we need ED, we need DC, and we need CB. Now these last two are sides of the square, so I guess we could shorten our work by saying, well, they're sides of the square, so they'll both be the same. So we'll get each of these, and we will add them all up. So it's 8 minus, and I can't remember, 8 minus, can't remember, it's 12 for the x-coordinate and 6 for the y-coordinate. ED, again, I'll put 8 first, so 8, 3, 8 and 3, 3 and 9, 3 and 0, and then 9 and 12, 0 and 6. Alright, so this is 4 squared, which is 16, plus 2 squared, which is 4. So root 20. This is 25, 25, so this is root 50. And what have we got? 6 squared is 36. Should be a minus. So 6 squared, 36, and then 3 squared is 9. So that's 45 squared. Sorry, square root 45. This one should also be square root 45, so this is 3 squared, which is 9, and 6 squared, 36, root 45. Alright, now, what are we to do? This I think this could be probably cleaned up a little bit. So root 20 plus root 50 plus root 45 plus root 45. I can take a square out of each of these. This is 2 root 5 and 5 root 2. Three root 5, and then another 3 root 5. So this is 5 root 2 plus 8 root 5. Now I'm a little, just a little tiny bit apprehensive about this, because I would expect them all to be something root 5. So let's just for a second double check our ED. Okay, that is. Let's see, that is on our picture, right? Yeah, ED, and that's 3,3 to 8,8. Yeah, I guess it's fine. I guess it's allowed to be sort of the odd one out. Just a little peculiar, but that's okay. And so that's our final answer. Not as clean as I would have expected, but it's certainly not 4 squares being added up, so that's not so bad. And that's it for question number 2 on our Galois paper. We've got so we're halfway done now. We've got questions 3 and questions 4 remaining. Question 3 is in 3 parts, and part C is so big we need another page. But we'll deal with that in the next video. So thank you guys for watching. I'll see you next time.